TAFE, New South Wales, Mount Druitt College, talking about PongSats and MiniCubes. And your talk, I think, is 10 minutes with questions?
Yes.
Whenever you're ready.
Okay. Good morning, ladies and gentlemen. PongSats and MiniCubes. That's just an outline of what I'll be talking about, the areas that I'll be covering. Why PongSats and MiniCubes? Well, PongSats are experimental containers, or dare I say buses, flown to very high altitudes and up to 30 kilometres aboard primarily high altitude balloon flights by a company called JP Aerospace in northern Nevada. PongSats themselves are literally table tennis balls with a diameter of 40 millimetres, maximum weight of 3 ounces or 85 grams. The MiniCubes are 5 centimetre plastic cubes with a maximum weight of 250 grams. Both represent a low-cost avenue for anybody, from school children to researchers, to access near space conditions. For educators, they provide an intermediate step to test concepts and subsystems for using CUBESATs before you commit to the larger expenditure. There's also, they provide an avenue for STEM education and STEM outreach programs. I'm not connected with the company in any way. I'm just doing it because it caught my eye and I'm interested in it. The company itself, JP Aerospace LLC, incorporated in 1979 and based in Sacramento, California. They conduct high altitude balloon flights and some rocket flights from a dry lake bed in northern Nevada. They run about 10 to 15 balloon flights per year. So far they've done 186 flights to date, flown about 18,000 PongSats and 30 MiniCubes. Recently they've started to fly CUBESATs as well to high altitudes. The PongSat itself, like I said, it's a bog standard table tennis ball, 40 millimetres. The beauty of it is there's no cost associated with the flight. There may be with shipping costs. There's no requirements for who can access the program. It's open to anybody and of any age and in any country. They normally fly about 300 to 400 PongSats per flight. They have flown up to 2,000, but they find that they don't do that too often because it's they find it logistically difficult. There is a PongSat launcher rocket which carries, that should be 30 PongSats. That's the PongSat rocket, launcher rocket. It's 89 inches or 2.26 metres and 3 inches in diameter, so it's 76 millimetres. Like I said, the most went to 100,000 feet. Some flights they've done up to 130,000 feet. The experiments themselves can be as simple as a seed or a marshmallow to something sophisticated like a data logger with a microcontroller. The PongSat flights use a standard flight payload platform. It's a deck about 1.5 metres, made from carbon fibres and foam, carries the payload as well as the payload as the flight systems. That's the high rack in flight itself. You can see there's the basket holding the PongSats themselves. You've got a shelf with racks on it. You can see there's a stacked MiniCube there, other MiniCube. They may also, if your experiment requires it, they may take your PongSat and place it on the rack so that it's exposed to sun, or so it's not amongst the rest of them. This structure here looks like I think it's a flight stabilisation sail for making sure that the high rack doesn't turn over or tip over upon landing. The return system, it's either balloon to release or ascension till balloon pops. Couple of rules: no insects or prohibitions, no insects or animals, no volatiles or combustibles. If you've got protrusions or radio signal emitting devices, you need pre-approval. And there's a PongSat user's guide available. The MiniCubes, like I said, 5 cm plastic cubes, 1 mm thick walls, with a camera tripod mount on the base. The base is 6 mm thick, so you're actually, your height within the void is 43 mm. Yeah. Yeah. The height within the void is 43 mm. That's the base itself with the camera tripod hole there, and I think that's an indexing hole. Apparently the MiniCubes can be flown on balloon or a rocket mission. There is a cost associated of $340, and you get a flight data sheet and CD with images and video. Some restrictions, pretty much the same as for PongSats. You can have protrusions, but the only thing is that they can't extend below the base since the unit's sitting on a shelf. The CubeSats, JPA's recently started flying CubeSats last US fall 2016. So far they've flown 3, and they see it as an alternative to having an undergraduate's completed CubeSat sitting on a shelf after completion. The cost at the moment is about $2,000 per flight. In conclusion, PongSats and MiniCubes represent a low-cost avenue for anybody to fly experiments to near space altitudes, and for researchers to test out concepts and subsystems before committing further funds to their CubeSat projects. They also represent an avenue for any STEM outreach programs. Also, JPA welcomes any feedback in way of photographs or commentary after flight. So there's some references and contact details should you want some further information. I apologise for the garish colour, but I couldn't find any way to change the link's font colour. Questions? Thank you.
Okay, any questions? Yep, in the end.
Quick question. Short of, someone's got to do it, is there any natural impediment to equivalent sort of operation taking place in Australia?
I only I actually started thinking about that as of 5 o'clock this morning. There is a CASA, Civil Airspace Safety Rules, Section 101, Section Regulation 101 for unmanned air flight. So I didn't have a chance, obviously, to read through it, but that may be something to consider. Yes.
Just on balloon flights, the International Space University, based at Adelaide, has done a number of balloon flights. They haven't done the sub-payload thing. They might be worth talking to.
Okay. Like this.
What are the chances of retrieving the payloads after it's fired?
The payload, they have a GPS and tracking data, tracking system available, and he's got a, when Mr. Powell, the principal of JP Aerospace, does it, he's not doing it by himself, he's got a whole team. So they do have a chase vehicle to retrieve the payload. And in any case, the PongSats and MiniCubes are returned to the initiator experiment.
So
Okay.
you don't have a number for the statistics of how many, you've flown a number of them, obviously.
No, not. I haven't. I'm thinking about it, and I'm in the process of putting something together.
Okay, that's enough questions. Thanks. Good talk.